Hi, I'm Jessica here at Nautilus Mission Control at the Inner Space Center in Rhode Island, and we're joined today by Chris Roman, who is a scientist and professor here at the Graduate School of Oceanography at University of Rhode Island, and he specializes in ocean floor mapping. So welcome, Chris. Thanks so much for being with us today.
No problem.
And I know we've been mapping the ocean floor throughout this entire expedition season. We started mapping shipwrecks. More recently, we've been mapping the geology of the ocean floor. Could you explain to us a little bit how that technology works?
Okay, so what we're trying to do is get the shape of the seafloor. In an underwater world, we call that bathymetry, which is similar to topography or topology for above ground maps. So we use acoustic sensors. So acoustics is a very versatile tool in underwater mapping. So you can send sound from a sonar to the bottom. It bounces off the bottom and comes back to you. And by looking at the time or how long it took the sound to go out and come back, and the angles, the directions it's bounced back to you, you can resolve this, use the vehicle, and create a map of the seafloor.
So is it a little bit like echolocation, like how dolphins see things?
It's exactly like that, actually. So you send sound out, it has to bounce off something and come back, so you're listening for your echo. The trick is you really want to be able to know where it came from. So much like we have two ears and we can hear, we can tell which direction sound comes from. Mostly if sound is, say, off to this side, it hits this ear slightly before it hits this ear. So I know, using that time difference, it came from over here. The sonars are quite fancy tools, and rather than having two ears, the sonar has maybe 20 or 100 ears.
Oh, wow.
So it listens to 100 simultaneous channels, right? A channel being from one microphone. And it can use all the little time delays between having a microphone over here versus here, and you can convert those time delays to angles, and you can figure out the direction sound came from. So every time you do a ping, we call it, in the sonar, you can figure out all the ranges and all the angles the sound came back from, and you get yourself a slice of the seafloor.
And why do we use this specific kind of technology?
We use a sonar because sonars well, the versatility of acoustics is quite high, so depending on your choice of frequency, low frequency sounds can go very far, kilometers, tens of kilometers, hundreds of kilometers underwater. High frequencies can go meters, tens of meters. So we're using a sonar right now that works to about 50 meters, and it gives us range resolution, meaning we can resolve things and see things that are differences on the order of 5 centimeters, so inches. So we've chosen to use a specific sonar that can give us information back that's sort of on the inch scale.
Oh, very cool.
Yep.
And why is it important to map the ocean floor?
Mapping and exploration are sort of tied hand in hand because I guess we really want to get the big picture, so to speak. And if you've watched the videos, you'll kind of notice that the visual images are really pretty small. You only have a certain amount of light you can put out there. It really can't back up and get a big picture and just take a step back and look at the whole horizon. So you're really, with an ROV, you're looking at the world through a soda straw, and you can only look at one little spot at a time. So it's very hard to get a big, comprehensive view of the world. So if you invest the time to map, meaning driving the ship or the ROV back and forth in a pattern that's regular over a large area, you can process that data and create a big picture of what's going on. And that's sort of what you back up and say, okay, this is what the whole scene looks like. So all of your more close-up encounters make sense in a larger context.
And we can give those maps to scientists that aren't on the ship all over the world.
Yeah, exactly. So the point is, if you invest the time to make a map, then you know, oh, I saw this here and this there. You get the context. You can ship the map and the images from Hercules and all the other data back and lay out the whole story of an area rather than just, again, looking through the world through a soda straw.
So what you do is very important.
I'd like to think so.
Well, thank you so much for being with us today.
Sure, no problem.
Again, I'm Jessica here at Nautilus Mission Control. Stay tuned at nautiluslive.org. And now back to the action on the ship.